In section 5.4, we're going to do complex fractions, and we're going to learn how to simplify what are called complex fractions. Now, you may ask, what are complex fractions? Well, let's go over to the whiteboard and look at what complex fractions are. So we want to ask, what are complex fractions? And complex fractions are fractions where we have a fraction divided by another fraction, let's say C and D. So we have two fractions that are divided, and they are usually they are of that form. And we want to be able to simplify these expressions because this is an expression, and we want to be able to simplify them. One way to simplify them is simply understand that A over B is divided by, let's say, C over D. Another way to simplify it is to look for the lowest common denominator of B and D and go through a procedure to simplify that. And we will go over both of these methods in the following examples. So here is the procedure for finding the rational expressions with different denominators. So this would be the lowest common denominator method. So we find the lowest common denominator. If the denominators are monomial terms, then the lowest common denominator is the monomial term, which is divisible by the given denominators. And if the denominators are polynomial type, we'll factor each denominator completely. So this should be sort of a review of finding a lowest common denominator. And then we multiply the numerator and the denominator of the complex fraction by the lowest common denominator that we found in our first step. And of course, we simplify lowest terms. So, as I said, there are actually two ways of doing it. So let's look at an example. Example number 1. So here we have example number 1. Where 3/4 is divided by 5/8. So let's look at what we would consider the lowest common denominator method. Well, we see 4 and we see 8, and we see that the lowest common denominator must be 8. So in order to keep things tidy, I'll multiply both the top and the bottom by 8 over 1. So I'm going to simplify these. And here I take 8 over 1 and 8 over 1 on both the top and the bottom. And I notice that 4 goes into 8 2 times, and 8 cancels out 8, so we are just left with 5. And that leaves us with 3 times 2 over 5, and 3 times 2 is 6. So our final answer is 6 over 5 using the lowest common denominator method. Now, let's try the other method. And this would be the multiplication method, or turning it into a regular division problem. So instead of dividing 5/8, what we do is we turn this into a regular fractional division problem. And then, as one usually does in a regular fractional division problem, we turn this upside down, turning it into a multiplication problem, and that's why this is called the multiplication method. And we see that 3 times 8 is 24, and then 5 times 4 is 20, and then we reduce, because 24 and 20, well, what do both of them both of them are divisible by 4, so 24 divided by 4 is 6, and 20 divided by 4 is 5. So you see, in this case, either method can be used. Now, with all these complex division problems, you could use either method, but sometimes one method works better than another method and maybe is more quick, and you can solve it in fewer steps using one method over another method. So let's look at example number 2. So let's go to the whiteboard and look at example number 2. So let's try and look at it if we had to use the multiplication method like we did in the previous problem. Well, that means if we were to use the multiplication method, in order to change this into a multiplication method, we would have to combine these two terms. So maybe that's not the best method to use. So let's try the lowest common denominator method. Well, what's the lowest common denominator in these? Well, we can see that the lowest common denominator is xy. So what we're going to do is we're going to multiply each of these terms by x over y. Or we can put it x over y over 1 to keep things tidy. So what I'm going to do is I have 1 over x times xy over 1 plus 1 over y times xy over 1. And then the bottom, I am going to do 1 over x, xy over 1 minus 1 over y, xy over 1. So now I'm going to proceed to simplify this. So I can cancel out the x here and the x here. I can cancel out the y here and the y here. I can cancel out the x here and the x here. And I can cancel out the y here and the y here. So let's see what I get after I do that. Well, after I do that, I end up with y plus x on the top because 1 now are the same. This is a plus sign. Let me just make that very clear. And then on the bottom here, I have y minus x. And there's nothing more we can do. We've simplified it as much as we could. So now let's go back to the PowerPoint of example number 2. So here it is a little bit more neatly written. So we want to simplify this. And we're going to use, as I mentioned, the lowest common denominator method because we don't want to combine these two, because if we were to use the multiplication method, we have to have one solid line here, and we see these are two separate fractions separated by a subtraction. So that's going to give us a lot more steps. So we're going to find what is the lowest common denominator of this. Well, as mentioned on the whiteboard, it's xy, and here I did the same thing as I did on the whiteboard, and then I continued to finish it up, and here I get the same answer. So for example 3, we want to simplify this. And as you see here, we're dealing with a situation that's more algebraic. So again, what I'll do is I'll first do it on the whiteboard, and then I'll show you it how I do it on the PowerPoint. We have x minus 2 over x squared minus 9. And all of this is over x squared minus 4 over x plus 3. So here, what we're going to do, let's look at this. Well, it looks like we have a nice solid line, so it may actually make the multiplication method easier than using the lowest common denominator method. So let's start out using the multiplication method. So what we're going to do is we're going to turn this ultimately into a multiplication problem. So we'll say that's equal to x minus 2 over x squared minus 9 divided by x squared minus 4 over x plus 3. And now we're going to change this problem into a multiplication problem. So we get x minus 2 over x squared minus 9 times, and I'll put brackets so everything's nice and tidy, times x plus 3 over x squared minus 4. So there I have that. Now, as we've learned before, we're going to have to factor everything out. So we're going to have to factor everything out before we cancel. Otherwise, we're going to start killing kittens, and we don't want to do that. So for the top, okay, so I'm going to look for here. So let me just factor everything out. So I have x minus 2 times x plus 3. And here I have the difference of two squares. So I have x plus 3, x minus 3. And then here I also have the difference of two squares. So I have x plus 2, x minus 2. Let me just extend this all the way out. All right. And now I can start canceling. So I can cancel this one. I can cancel this one, I can cancel this one, and I can cancel this one. And so remember, I must put the 1 on the top, because remember that a fraction is different than a whole. So it's x minus 3 over x plus 2. So it's very, very important that I put this 1 on the top. Not just write this, because remember that a quarter of the pizza pie is not the same thing as 4 pizza pies. So if you end up canceling the top out, it means it just leaves you with a 1 on the top. And that's very, very important to mention, to note. Otherwise, you'll get the wrong answer. So let's look at example number 3 on the PowerPoint. Well, like I did on the whiteboard, I used the multiplication method here. And as you see, I changed first into a division problem, then I changed it into a multiplication problem, and I factored and canceled, just like I did on the PowerPoint. On the whiteboard. And remember, this is a 1. Even though these two cancel out, it makes a 1. It doesn't. A fraction does not become a whole number. A fraction remains a fraction. Now, for example number 4, we want to simplify this. And this one, well, we look at it and we see that we can probably use either method for this one. So what I'm going to do is I'm going to solve this by both the multiplication method and the lowest common denominator method on the whiteboard. In example number 4, we have 1 plus x over y, and the entire thing divided by 2x plus 1 over y. Now, the thing is, looking at this one, it looks like we can use either method. So let's try both methods. So I'm first going to use with the multiplication method to solve this, because I have that nice solid line here, which means that it would make the multiplication method a little more straightforward. Well, let's see what happens. So I'm going to now change this to 1 plus x over y, and I'll keep it tidy, divided by 2x plus 1 over y. And now I'm going to change that into a multiplication problem. So now I have 1 plus x over y times, let's make that times look good, times y over 2x plus 1. So there I made it into a multiplication problem. But now I have to combine these two, because I can't just multiply it like that. Let me just extend this line a little bit. So it turns out well, if y is the lowest common denominator here, well, it turns out that 1 would be y over y. So that would be equal to y over y plus x over y. And then I'll multiply that by y over 2x plus 1. So now I'll combine these two. Oh, sorry, this has to be an x, sorry, x. So now I'm going to combine these two. So I'm going to get y plus x over y for my first term here. And now I'm going to multiply that by y over 2x plus 1. And it turns out that these two y's cancel out, and then I'm left with y plus x on the top, and then on the bottom I have 2x plus 1. And I stop there. I don't want to cancel anything more out. I don't want to touch it because I don't want to start killing kittens. And that looks really good. Now, so that's using what one would call the multiplication method. Now I can also, let's see what would happen if I use the lowest common denominator method, because that doesn't look that difficult either for this one. Because if you notice what the lowest common denominator here, well, it turns out it's y. So I'm just going to erase all this here. So here we go. So now I'm going to look for the lowest common denominator here. So lowest common denominator here is y. Okay, so that's fair enough. Or we can say y over 1 to keep things tidy. So now I'm going to multiply through everything by y over 1. So I have here the first term, 1 times y over 1 plus x over y times y over 1. And then the bottom, I do the same thing. 2x plus 1 over y times y over 1. Okay, so here I end up with, on the top, so let's see. Well, here the top, these y's cancel out. These y's cancel out. So it turns out I go y plus x over 2x plus 1. So it turns out that with either method, I get the same answer. I think maybe the multiplication method had maybe 1 or 2 more steps, but it really doesn't matter which method you use. Sometimes one method will be shorter than the other one. Sometimes one will be longer, but either method is actually good, so long as you follow all the proper steps, because as you see, I got the same answer regardless of which method I used. Now let's see what I did on the PowerPoint. Which method did I choose on the PowerPoint? Well, the method I chose for the PowerPoint was the lowest common denominator method. So I saw, just like on the whiteboard, that the lowest common denominator was y, and then I multiplied through everything by 1 over y until I got my final answer, which was exactly the same. For numbers 5 and 6, I would usually have you work it out, whatever method you would prefer. But given the circumstances, I'm going to work them out for you in the method that I think is most appropriate, but you can use whatever method you like and that you think is the best for you. So in number 5, I look at number 5 and I see, well, I don't have a nice simple fraction here that I can turn into a multiplication, but I see that I can easily find the lowest common denominator, which I find is 6xy. So I'll just multiply everything through by 6xy over 1. And so I do. 6xy over 1, 6xy over 1, 6xy over 1, and then proceed to simplify that by 3 goes into 6 2 times, 6y, 6y I cancel out here, and then I cancel out the x here till I finally get this. So then I get this, and I see if I could simplify that any further, and it turns out that even factoring doesn't help me that much because I cannot really simplify that any further. In example number 6, I decided, because it's easy for me to figure out that since the denominator here is 2, that this is going to be 4 over 2 to make 2. So I decided in this one to use the multiplication method by just a little bit of algebra here. So here I do it, and here I have, so now I have 2 in the bottom, 2 in the bottom here, so it's nice to combine those. So what I do is I combine them, and then I turn it into them both into a regular division problem, and then into a multiplication problem. I see my 2's cancel out, and I get my final answer, x plus 4, x minus 4. Now again, you can do this one using the multiplication method and this one using the lowest common denominator method, but it may add a few steps on, but that's okay, just so long as you get up the mountain and to the right house. So thank you very much, and be well and take care, and hope you enjoyed this video.